Hello everyone, welcome to lesson number 9 for BC Calculus. This lesson is on derivative graphs. We're going to be doing a lot of stuff with derivative graphs. We're going to analyze them, we're going to talk about increasing and decreasing, we're going to compare them to f of x functions and what they're doing. So there's a lot of stuff going on in this lesson, so we're going to dive right on in. So one of the things that I can do for my students here is say that this is a graph and it's asking you to answer the questions that's right here based on the graph above. So this is a warm-up that I do with my students. So you guys can see the graph here, and then these are all the questions that that I would ask them just to see what they can remember from pre-calculus. So I'm going to go over a lot of this stuff when I go over my videos. So let's talk about it now. So for 4.1, we're talking about increasing, decreasing, and concavity. And so one of the things that we want to really truly make sure that we get as far as talking about the nomenclature, how to actually get into what stuff means. So I'm going to go ahead and draw a little straightforward, very simplistic graph, pretty basic. And I'm going to call this 0. I'm going to call this point right here 1. I'm going to call this peak down here 2. I'm going to call this 3. And actually, let's go ahead and do this as well. Let's continue down with it. So we'll call this peak here 4, and we call this 5. And we're going to call this graph f of x. Okay, so this is going to be our f of x graph. In this video set, I should say, if this is f of x, it tells us a lot of good stuff. If this f prime of x, it tells us something completely different. So my job in the next couple of videos for this lesson is to make sure that we can look at this in terms of f of x, and then we're going to come back and look at this graph as terms of f prime of x and what differences it's actually going to tell us. So let me actually do something really fast. Okay, so the first thing that I want to do is I want to talk about what's happening from 0 to 1. Okay, from 0 to 1, and then also from 1 to 2. So from the interval from 0 to 1 and 1 to 2. So let me just go ahead and say from the interval from 0 to 2. I want you guys to notice that if we're standing here on this function, this f of x function, and we start walking down it, right? Let's say that we're on top of the hill, and so we're walking down it. We're literally decreasing, right? We're decreasing. So f of x, our actual function, is decreasing, right? It's decreasing. So what does that mean about our derivative? Well, our derivative is quote-unquote the rate of change, right, of our function, and you guys can think about this, because we're talking about graphs, let's be honest here, you kind of think about slope. Okay, so you can be thinking about the slope here. So when f of x is decreasing, we say that f prime of x, which is our derivative, is actually going to be negative. Okay, I'm going to make this very clear right off the bat. You never ever want to justify anything in this class as a slope is positive or negative. Instead of saying slope, say that's the derivative. Okay, do not say it. What is it? The function, the derivative. And do not say it's above or below the x-axis. Okay, you want to be very careful. It's positive or it's negative. Those are the kind of things that we're going to get really good at saying in this particular video set, I should say. And then from 2 to 4, right, so now we're going to keep on walking on our little path, and from 2 to 4, we can now say that f of x is increasing, right? We're going up. We went from a valley, so it's increasing. So now that means that f prime of x is going to be greater than 0, or we can say that it's positive. Just like up here, we could say that this is negative. And then I'm going to go ahead and say now from 4 to 5, f of x is decreasing again, so we're starting to go down again, right? And again, f double prime of x, the f of x is going to be less than 0. All right, so that's a very straightforward example of what you see is what you get. Okay, what you see is what you get. Now let's talk about the second derivative. Even though it's not up here right now, I just want to talk about the second derivative for a second, because we did talk about that a little bit with particle motion. So if I look at the second derivative, well, what is that really telling me? So from 0 to approximately somewhere right here, all right, so we're going to say 0 to approximately 1, we're going to have something that is concave down, right? Here's our sad little face. Concave down. So we're going to be concave down, and here on out I'm going to abbreviate that as just CD. Okay, concave down. And what that means is that our second derivative is going to be less than 0. And you can also see kind of where else it's concave down. So approximately between 3 and 5, we also have another sad picture, right? So our graph is concave down. So from 3 to 5, I can also say that we're concave down. And then if I look at 1 to 3, there's our happy face, right? There's our happy face. So from 1 to 3, we're going to be concave up, which means that f double prime of x is going to be greater than 0. And again, it's what you see is what you get. And so our point of inflections in this particular example are going to be at x equals 1, x equals 3, well, x equals 1 and x equals 3, right? And that's where our concavity changes signs. Okay, so that's the idea. Now, with that being said, it says, how does our first derivative help us find maxes and mins of a function? All right, so now we want to talk about maxes and mins of the function. So this is what you do with that, and my graph is a little crazy. So let me pause it here, and let me go back and draw my simplistic graph. Okay, so we're going back here, and so I want to just talk about how our first derivative helps us find max and mins of our function. Now, again, what you see here is what you get. So we can see that there's a local min right here at x equals 2, and there's a local max at x equals 4. And so this is going to go into the conversation we're going to have when we actually look at derivative graphs. But check and see what's actually happening. What's our derivatives doing at x equals 2 and x equals 4? So if you look back here at 0, remember, we were decreasing. We were decreasing this entire time. So f prime of x was negative all the way here. But then what happens when we're going to go in this direction? So from 2 on, this is where f prime of x now becomes positive. And then what's going to go on here? This is where f prime of x becomes negative. And this is the very first point that I want to truly make about how to find max and mins when looking at the first derivative. So again, I'm going to pause it, I'm going to erase all this stuff, and I'm going to come up with what you should know. Okay, so now I've erased everything. Let's talk about max and mins. Max and mins. Okay, so the first thing that we're going to talk about here is that f prime of x changes signs. Okay, so that's the very first thing you guys we're going to get from this lesson. So I know I'm already almost 8 minutes into this video, but this is the first thing. I'd like to do a lot of explanation for this lesson because it does require a lot of thinking. So to find a max or min, we know that our derivative is going to be changing signs, right? And so let's go a little bit more specific in what we know. So let's talk specifically about maxes. What's happened at a maximum? So here's a maximum here. Notice that my derivative was positive, and then it becomes negative. So we can actually go more specifically and say that our derivative changes from positive to negative. And you guys can abbreviate this on any exam that you want to. You don't have to say positive and negative. You can write plus to minus. And so our minimum, right, our minimum, if you guys look at what's happening for our minimum, well, we're negative and then we're positive. And I just tell students to think about that for a second. I think that pretty much makes common sense, right? And so if I'm function and I'm going down, if my slope is negative and then all of a sudden I stop, and then my f of x changes signs to positive, then I have to have a minimum there. So what else can we say about this? What else can we say about the max and mins? So we can also say that f prime of x is actually equal to 0 at max and mins, right? That just means that there's a horizontal tangent here, and there's a horizontal tangent here. So if you're trying to find a max or a min of a function, you just have to find the derivative and then set it equal to 0. Then you can do a number line, and we'll do some of these, and don't worry. Then you're going to do a number line, and you can see what's happening around them. If I'm positive and negative around A, then what this means is that I'm going up, and then I'm going down. So I know that this has to be a relative maximum. If I go and do A, and this is negative positive, then this is going to be, I don't know why I drew it like that. No idea why I drew it like that. If it's going to be negative and positive, then I'm going down and coming back up. Well, this is going to give me a relative minimum. So there's a lot of information thrown out there to you. But really, saving grace, what we need to know here is that. So what we need to get out of this is that at a max or a min for an f of x graph, the f prime of x changes signs. So let's do an example. Let's show a little bit more of what to do here. So that was the background for this particular question. Let's look at the derivative graph. So let's actually talk about it in terms of this graph right here. So now we're given the graph of f prime of x. This is a graph of, and I always tell this to my students, this is the graph of slope. This is the graph of slope, even though I don't like to say that. It's really a rate of change. Okay, I'm going to clarify that. It's a rate of change, but it's a graph of the slope of f of x. Okay, this is your first being introduced to this, so this is slope. So what I want you guys to understand is that there's a relative max at x equals blank. So we talked about that before. So let me really quickly do one thing. I want to show you guys one quick thing here, because not what you see is what you get. Okay, not what you see is what you're going to get. So I'm drawing 4 pieces of interest, and I want you guys to know that anything to the left of this right here, my derivative is less than 0. The value of it, right? The derivative is less than 0, because this is the graph of f prime of x. So this means that my derivative is negative. So we just talked about that on the previous example. If f prime of x is negative, then I can say that f of x is decreasing. And this is what's confusing to students, because you see that there's a slope that's positive here. That has nothing to do with it. That talks about concavity. So when my derivative is less than 0, the value of this is less than 0, then f of x is decreasing. If I go and look at what's happening here to here, the value of f prime of x is actually positive, right? Because I'm above the x-axis, but we never say that, because we just say that f prime of x is greater than 0. So that means on this entire interval, I can say that f of x is increasing. And so here's how I'm going to break it down to you right now. What's going on right here? So here's how I tell students, this is my little silly story for them. So at this moment in time, I'm going to start giving you money, right? Already sounds good. I'm going to start giving you money. And I'm going to start giving you money in higher increments. So maybe I start you out with $1, then I'll start giving you $5, then $10, then $20. So you're getting richer faster, right? So you're getting higher faster. Here, I'm still giving you money. So let's say I started giving you $100 here. Now I give you a $50 bill. Now I'm going to give you a $20 bill. Now I'm going to give you $10. You're still earning money. But you're earning it at a slower amount of money. And then, you guys guessed it, now when I get down here in this, now you're starting to give me money, right? So this is the same thing as this. F prime of x is less than 0, and that means that f of x is decreasing. And then finally, you can say up here in this example that again, we are increasing. So just think about that for a second. Okay, think about that for a second. So that's the idea behind that. And I'm going to erase all this and we're going to talk about this for a second. But just kind of think about that when the values are, so let me do this. So let's do it this way now. So let me explain it to you a little differently and see if this part will help you. Because that was a lot. That was a lot going on. So I want you to do, instead of doing all this stuff, I'm going to say that my derivative is negative here. And then my derivative is positive here. Because again, I'm looking at the y values. So if I'm negative, that means my slope is decreasing here. And then I'm positive. So I know that this has to be a relative minimum. And remember, we talked about this earlier in this video. This right here is where f prime of x is equal to 0. So I have to be in a max or min here. So now I've already said, where is their relative max or relative min? Well, it's going to be, you have to first look at where the derivative is equal to 0. And so where does this value, where do these graphs actually hit 0? Not up here, not down here, right? So that's it. So now I can continue on with this example and say at this point, I'm positive, right? Because again, it's above the x-axis, and then I'm negative, and so I'm positive. and then I'm negative. So I know that there's got to be a relative maximum there. And so we can now answer this question, where is their relative maximum? Well, there's a relative maximum at x is equal to d, since our derivative changes signs, and this is how you will always justify this, since f prime of x changes signs from positive to negative. I am increasing, and then all of a sudden I'm starting to decrease. So that's going to give me a relative maximum. So can you guys figure out where the other relative maximum is? You're going to find where does f prime of x change from positive to negative. So hopefully you have figured out where that actual other point is. And that's going to be right here at h. I am positive, and then I am negative. So I'm going to also say that there's a relative maximum at x is equal to h. Right? That does not look like an h, but that's my h. All right, looks like a fancy L. So what about a relative minimum? Well, we've actually already had a conversation about that. We know that there is a relative minimum at x equals b. And you can say the same logic here at f. I'm negative, and then I'm positive. Okay, I'm positive. So at x equals b, and x is equal to f. And another thing I tell my students is that when you're trying to find a relative max or relative min, you really just want to look at the y values. Okay, you really want to look at the y values and see how they're changing. So how is this guy changing? If it's negative and then positive, we have a minimum. If it's positive to negative, we have a maximum. All right. The other thing I just want to say about this is that where are we looking? We're looking for this where our derivative, again, is equal to 0. So we're looking at the x-intercepts. And again, we do not justify by saying x-intercepts. We say where the derivative is equal to 0. All right. So that's the max and mins from the first graph. So we're going to go ahead and finish up this video with two problems. And let's look at the first one. So it says the graph of f prime of x. The derivative of f of x is given to the right. So one of the things that I always have students do is really just make sure that we're looking at f prime of x. So we've kind of talked a little bit about relative extrema. So we did that one in the last little example. But let's talk about on what intervals is f of x increasing and decreasing. So I got a really easy way of discussing this to you guys and telling you what we're doing here. So I want you guys to remember that if my derivative is the function, if it's positive, right? So we talked about this at the very beginning. F of x is increasing when f double prime of x is positive. So we discussed that in that first little part of this video. So where is f of x increasing? Well, let's look at it. So f of x is increasing. All right, it's increasing on the interval from -5 to approximately, let's say, -3.3, something like that. Okay, because again, the graph is positive from here to here. And then it's also increasing from, let's say, -1.5 all the way to, let's say 0.75 maybe, or maybe let's just go 1. Let's approximate here. Let's go 1. And that's it. And so notice how I've highlighted this. And this is pretty easy to do. Where is it increasing? The function's increasing where f prime of x is greater than 0. Well, where is f of x decreasing? Well, that's going to be where our derivative is going to be less than 0. So it's going to be on this interval right here. So f of x is decreasing on the interval from -3.3 to -1.5. And it's decreasing from, let's say, 1 to 6. 1 to 6. So what are my explanation for this? Your explanation is only what I've written right here. So how do you justify when f of x is increasing? You just have to say that f prime of x is greater than 0, or f prime of x is positive. That is always going to be your justification for that. Where is f prime of x decreasing? Again, where our derivative is less than 0, or where our derivative is negative. One more thing I want you guys to take out of this is, again, I want you to look at the y values of f prime of x. When I'm above the x-axis, again, positive, my function increasing. So when I'm above the x-axis, f of x is increasing. And when I'm below the x-axis, f of x is decreasing. Okay? And that's the easiest way for me to tell you that question. Now, if we look what the second part of this is asking us is, okay, so determine whether there are any relative extrema and where will they occur. So the first thing is relative extrema. Well, that's just asking us for our, where is f of x have a max or a min? So again, the first thing we do is we look at where our derivative is equal to 0. Where are our key points? So here, here, here. Now technically, we're not looking on the endpoints. For relative maximins, we only care about what's in between. When we get to absolute extrema, which we'll get to a little bit later on, then we're going to care more so about that. So we've actually already figured out these answers. So let's look at what's happening with a relative maximum. So a relative max is going to be where, so again, we're positive and then we're negative. So positive, and then we start becoming negative. So at this value right here, which I think we call negative 3.3, at x equals negative 3.3. We're positive and negative. And then where else? So from here, we're negative to positive, so we'll get to that in a second. And then here, we're positive to negative. So at x equals negative 3.3, and then also at x equals 1. And the justification that you will always write is that f prime of x changes signs, okay, from positive to negative. And just visually think about that. If I'm going up, slope is positive, and then all of a sudden it's negative, it had to change signs from positive to negative. That's going to give me a relative maximum. Okay, a relative maximum. So that's the answer, and this is the justification. So I'm going to try to highlight everything here in different colors for you guys. So this is going to be your answer for relative maximum. I'm running out of room here. Relative maximum, and this is going to always be the justification that you're going to use for that. And so where else I can find room is for the last one is, well, where is this going to have a relative minimum? And relative minimum is going to be at x equals, what do we say, negative 1.5. And it's going to be the same justification as before. We're going to say now that f prime of x changes signs from negative to positive. Okay? Negative to positive. So with all that being said, and let me actually slightly try to circle that in. So what I've circled in this problem here is the justification. And by the end of this lesson, I will write down a summary for all of this, because this is, it's a hot little mess going on with these problems, I imagine. All right. So now that I've said that, I'm hoping we're getting this pretty well. So right now we're just talking about this. So you guys can, I'd suggest, pause it, practice this question. It's a much nicer function, right? And see if you guys can do A, B, and then be very curious to see if you guys can graph a possible function for f. Now, I'll be honest with you guys, you're only going to have to do these two things for me. I'm not going to have you graph anything, but yeah, you can always try it. So pause it, and then come back and we'll answer the questions. Okay, so let's look at the first one. So again, it's telling us that we have the derivative of the function f of x. So this is our graph of our derivative. It's asking me where f is increasing. So once you see increasing and decreasing, I want you guys to think about y values. Okay, the y values of your graph. So f of x is increasing, okay, and hopefully you guys got this already, from, let's just say, negative 3 to negative 2. And it's also increasing from 0, ooh, this is a good one, 0 to 2, right? We cannot include 2, and then 2 to 3. And the reason why is that f prime of x is greater than 0. Include and go from 0 to 3. So remember, it's positive from negative 3 to 2, and it's positive from 0 all the way to 2, but then it actually hits the x-axis at x equals 2, which means that this value, f prime of x, is actually 0. So we cannot include it increasing because it's fast, it's increasing, it stops for a second, it plateaus, if you will, and it comes back in. So it kind of looks maybe something like this, something like that. All right, so that's kind of what that graph is doing. If I want to talk about where f prime of x is decreasing, Well, it's just going to be from -2 to 0. And again, your justification is f prime of x is less than 0. It's that simple, ladies and gentlemen. Okay? It's that simple. Well, hopefully it's becoming that simple is what I should say. Whereas there are maximums, so f of x has a maximum. Well, for these, you're going to look at where f prime of x is equal to 0. So I have 3 candidates. I've got 3 candidates. So again, I'm looking at the fact that this is positive and this is negative. Positive and negative means that there's a relative maximum there. So at x equals -2. And I can say that f prime of x, the more you practice, you better get at this, right? Changes signs from positive to negative. And I know that in the very first example, I just wrote f of x changes from positive to negative. I need to include the word signs here because you need to figure out what f of x is changing. Okay, signs, values, what is it? So we want to make sure that I stress that with you, that you want to add the word signs to that. F of x has a relative minimum at x equals 0, right? Because I'm at negative and I'm at positive. So f of x changes signs from negative to positive. And so what's happening at 2? Right, so what's happening at x equals 2? So I'm positive and then I'm positive again. So like I said, you can see that this is kind of the graph idea of this. And it's not really, there's no max or min here. So where's that x equals 2? All right, there's a point of inflection here. So that's a good little point. And that's going to be part of our second video. Because right now we're all talking about just the first derivative. All right, the first derivative. So that's where I'm going to leave you in this video. We will do some more examples. And eventually later in the course, we're going to actually look at functions themselves and actually talk about max and mins as well. Okay, so hopefully you guys were able to follow that along pretty well. I know it was a very lengthy video, but like I said, this is that lesson that requires a good amount of thinking before you truly understand it. So hopefully you guys did. And like I said, in the last video of this of this lesson, I will definitely try to do a summary page and write down everything in one spot for you so it doesn't look like this hot mess that you guys see right here. All right, so we're going to come back in the next video, and I'll see you guys then.